everyone, this is our type 2 example. So in this type of example, we have to find out center of mass. The word is mass. Mass means weight. Okay. And second one is center of stiffness. So stiffness means at which point your load is to be distributed. Okay. So now, first of all, we have to find out four definition. What is the meaning of center of mass? What is the meaning of center of stiffness? Now, at any building, your center of mass and center of stiffness is acting at the same point. Otherwise, some moments are to be generated. So, what is the meaning of the distance between center of mass and center of stiffness? So, you all know that the word is eccentricity. Okay. So, what is the definition of static eccentricity? And at last, what is the definition of design eccentricity? Okay. So now we have to find out, or first of all, we have to define four definition. So first is center of mass. So what is the definition of center of mass? The definition is the point through which the resultant of masses of a system acts. So in any system, there are lots of masses of having different weight. If your system is acting uniform mass means at all system your mass is uniform, then your center of mass is exact at the center. But if on a system there are various mass value, then your center of mass is not at a center. So in this type of example, we have two types of example. First one is uniform mass distribution and second one is non-uniform mass distribution. Okay. So the definition of center of mass is the point through which the resultant of the mass of a system act is known as center of mass. Second definition is center of stiffness. So the center of stiffness is the point through which the resultant of the restoring force, okay, restoring force of a system act is known as center of stiffness. Now it is already discussed that your center of mass and center of stiffness is at same point. If it is not at the same point, then some moments is generated on this system, and this distance between center of mass and center of stiffness is called as eccentricity, which is denoted by E. Okay. So the next definition is static eccentricity. So the definition of static eccentricity is it is the distance between center of mass and center of stiffness of floor I, means at respective floors. And the last definition is design eccentricity. So design eccentricity is some value, and the equation of design eccentricity is given on IS code. So this is the photo. So it is the value of eccentricity to be used at floor in tension, or it is torsion calculation for design. So there are two formulas to find out design eccentricity. So first one is 1.5 ESI. So what is ESI? ESI means static eccentricity plus 0.05 into BI. Now the term BI, you can see that the floor plan dimension of floor I perpendicular to the direction of force, means this is 4 meter and your force is acting on this side, then the value of BI is 4 meter. Okay. If your building having 6 meter length and your force is acting on this side. So your value of BI is 6 meter. So this plant dimension perpendicular to the plant dimension. So this is your first formula, and your second formula is ESI minus 0.05 BI. Now you have two values, but which value for which value you have to design. So it is clearly mentioned that whichever of these gives means from both the values more severe effects means maximum values. Okay, because maximum value gives us to more severe effect in the shear of any frame. So this is the definition of center of mass, center of stiffness, static eccentricity and dynamic design eccentricity. Now we have to start our first example in which there is uniform mass. So you can see that in uniform mass example. So this is uniform mass distribution because this is your table. This is the plan of table in which there is no any particular different mass are there. Only plain table are there. So this horizontal direction means this horizontal dimension is 10 meter and vertical dimension is 8 meter. So this is the revision of MOS, mechanics of solid, in which you have to consider lower left corner as a origin. So we have to consider this point as origin. Okay. So what is the value of XM? XM means center of mass in X direction. So whenever your system is act as a uniform distribution, your center of mass is at the exact center point. So this is your exact center point. Okay. So this length is 10 meter in X direction. So your center of mass is exact at the 10 by 2. So it is 5 meter, and your y dimension means this dimension is 8 meter. So your center of mass in y direction is at 8 divided by 2, which is 4 meter. So this is your 5 meter in x direction and 4 meter in y direction. So this is the value of center of mass in uniform system. Now we are moving further to the second example in which there is uniform mass distribution are not there, means non-uniform mass distribution. Okay. So now let us start our example number 2 in which you can see that locate the center of mass, means you have to locate on this system at which point there is center of mass for the building having non-uniform distribution of mass. It is clearly mentioned that if there is no any clarification depending it is uniform distribution or non-uniform distribution, but you can see that this left corner having 1400 kg per meter square. This is 1200 kg per meter square, and this portion is having 1000 kg per meter square, means this system is having non-uniform mass distribution as shown in figure. Okay. So first of all you have to find out all this portion in kg per meter square to kg, because your weight, mass means weight is always in kg or kilonewton. Okay. So first of all we have to divide this figure into four different part because a geometrical design. Okay. So this is your rectangle portion of having length. This length is 10 meter. You can see that this is 10 meter and this length is 6 meter. So this geometry is perfect. Second one is this length is 20 meter and this length is 4 meter. Okay. But this geometry is not looking good. So you have to cut this portion like this, or you can also this portion like this, but we have to cut this portion into vertical portion. So this is your part number 1. You can see that over here. This is your part number 1, this is your part number 2, this is your part number 3, and this is your part number 4. And as we have discussed in mechanics of solid, that consider lower left corner as the origin. So this is your origin, means this is your 0 0. So first of all you have to convert kg per meter square to kg by multiplying some area. So what is the area of this portion? The area of this portion is 10 meter in x direction and 6 meter in y direction. So your area is 10 into 6. The area of second portion is 10 meter in this direction, and this direction it is also 10 meter. In third, this length is 20 meter. You can see that this is 20 meter, and what is this value? This value is 10 meter. So the area of third portion is 20 into 10. And what is the area of fourth portion? The area of fourth portion is, this is 20 meter and this is 4 meter. Okay. So first of all, we have to convert all the masses. So you all know that in mechanics of solid there are three types of example: line, area and volume. In line type of example, your equation is L1x1 plus L2x2 plus L3x3 plus up to ln xn divided by L1 plus L2 plus L3. But L means length, but in this type of example you have to consider as mass. So mass means weight. Weight is denoted by W. So your equation is W1x1 plus W2x2 plus W3x3 plus W4x4, because in this system we have to convert all the system into four different shapes. Okay, divided by W1, W2, W3 and W4. So W1, this W1 is in kg or in kilonewton. So first of all 1400. So this 1400 is in kg per meter square. So we have to convert kg per meter square to kg by multiplying with area. So what is the area? Area is 6 into 10. It is already discussed in our last slide. Into 5. So you can see that this is your part number 1. So this length is 10 meter. So what is the distance of CG? The distance of 10 divided by 2. So our value of x1 is 5 meter. This is our part number 2. So this length is 10 meter. So your value of x2 is also 5 meter. This length is 20 meter. So the CG is at this point. So 20 divided by 2, so 10 meter from this length, but you have to consider all the dimension from origin. So 10 plus 10 is equal to 20 meter. So for your value of x3 is 20 meter, and similarly your value of x4 is also 20 meter. So this is the calculation of x1, x2, x3 and x4. Similarly in y direction, this is your part number 1. You can see that over here. This total height is 14 meter. You can see that 10 plus 4, and this height is 6 meter. So you can consider this height is 8 meter. Okay. So this is your 6 meter height, in which your CG is at 3 meter. But what is the value from 0 0? From 0 0, it is 8 plus 3, which is 11 meter. So your value of y1 is 11 meter. Your value of y2, the value of y2 is, this length is 8 meter. So 8 divided by 2, which is equal to 4 meter. Your third portion is this. So this height is 10 meter. So CG of 10 meter is 5 meter. So your value of y3 is 5 meter, and this is your fourth portion. So for fourth portion, the height is 4 meter, but the CG is at 2 meter. So what is the value from origin? The value from origin is 10 plus 2, which is equal to 12 meter. So this is your value of x1 to x4 and y1 to y4. So after putting all this value, we will get our answer of xm is 14.652 in x direction, and in y direction your CG is 7.383 meter. So our final answer of center of mass coordinate is 14.652 and 7.383 meter. Okay, so this is our example of to find out center of mass only. In next lecture, we have to find out center of mass and center of stiffness in example number 3. Okay, so this is the end of today's session. Thank you.